So here's our sample problem that we're going to be working on. And the first thing that I'm going to do is I'm going to realize that my given compound, so here's my given, is not the same as my wanted compound. Okay? So given does not equal wanted. That tells me that I'm going to need mole ratio. And so I'm going to need a balanced chemical equation. So dinitrogen pentoxide is N2O5, decomposes into nitrogen dioxide, NO2, plus oxygen, O2. All right, then to balance this, I would first put a 1 here and then try to make it work with 2, and what you're going to find out is that's just not possible. So the next step would be to put a 2 here, which means you'll need a 4 here, so that balances the nitrogens. Then I have 10 oxygens on this side and 10 oxygens on that side. Okay, so now let's come up with a plan. All right, I want the volume of NO2. So that's going to be liters NO2. Okay, now I'm given a temperature and a pressure that are not STP, so I'm going to have to use PV equals nRT. Okay, so I have pressure, I have temperature, R is a constant. I'm trying to find the volume, which means that I need the number of moles. So I need moles, NO2. Okay, and I will get the moles of NO2 from the moles of N2O5, which is my given. And then the moles of N2O5 I will get from the volume of N2O5. And the nice thing here is that this is at STP, which means that I can use the molar volume of a gas. All right, so that's molar volume. And this is just going to be a mole ratio. All right, so when I look at this, I can see that these 3 steps are all one-dimensional analysis, and then I'll have to break out and do PV equals nRT. So my dimensional analysis is going to be question mark moles NO2 equals 5 liters of N2O5. And that's 1 mole N2O5. I'm using molar volume, so that's 22.4 liters. Okay, let's scroll up a little bit. All right, so liters N2O5 go away. I'm at moles N2O5. And I can take that to moles NO2. And from the balanced equation, there are 4 moles of NO2 for every 2 moles of N2O5. And that's as far as we want to go right now. All right. So I would get 0.4469, 64. When I plug this into my calculator, 0.446429 moles NO2. All right. Now I've got the number of moles of NO2, and I need to find the volume, so that's PV equals nRT. Okay, I need to solve for volume, so divide both sides by pressure. And I'm going to need a little bit more room here. So V equals nRT over P. And remember that I always say to do R first. 0.0821 liters times atmospheres over moles times Kelvin. Okay, I can do the temperature, which is 337.65 K. And I can do the number of moles, which I just solved up here, 0.446429 moles NO2 over 1.76 ATM. When I solve that with 3 significant figures, I get 7.03 liters NO2. Okay. So this, again, a very standard gas stoichiometry problem. Good luck.